day, my ladies and gentlemen. How was your night? How are you doing? Okay, now today we're looking at conversion between binary decimal and what? Hexadecimal. Okay. Now we're going to be having about six, if I'm not mistaken, six different distinct ways we're going to be doing this stuff. So our binary, we're going to be saying how to convert it to what? Decimal. So let's start with what? Converting from binary to what? To decimal. Okay. Now for our binary to decimal, it's quite easy now. So let's say you are giving a situation like equation like this. This is 1 0. Sorry. Okay, let's continue. 1 1 0. You're giving a question like this to. This is a question in what? A binary. Normally having this base 2. But how you know it's binary is because it's having what? 0 and 1 0 and 1 0 and 1. But to be more specific, we normally put it the base. The base tells you what this thing, because this can also be in base 10, but we will not know. But when they are specific about it, we know. So this guy is in binary. I want to convert it to what? To decimal. I want to convert that guy to what? To decimal. Now, okay. The first it's very easy, quite easy. Just don't get scared. It's very easy. First thing you just do, call your what? 0. Here to be what? 1. Let's say 1 now. 0. Next one is, let me call here 0. The first one will be what? 1. Next one will be what? 2. Next one will be what? 4. Next one will be what? 8. And the next one will be what? 16. Now you might ask yourself, where am I getting all these values from? This is simply just for the first one, it is just 2 raised to power what? 0. The next one, it is what? 2 raised to power 1. This one, 2 raised to power 2. The next one, 2 raised to power 3. 2 raised to power 4. That's it. 0, 1, 2, 3, 4. So 2 raised to power 4 is what? 16. I do for this. So this is actually a shorter cut. There's a way we normally do it where we start putting our 0, 1, 2, 3, 4. And we then start doing 1 times 2 raised to power 5 and all that. But that thing is time consuming. It's just good that you know this. 1, 2, 4, 8, 16. The next one will then be what? 32. It goes in that order. Just like that. Understand? So anyway you prefer to do it, you're good. You're going to be getting the same answer. So from this, any place you see 0, you neglect that one. So what means we're going to be neglecting what? 8 and what? 1. So we are going to be having this to be what? 16 plus 4 plus 2. This will give us what? This is 16 plus 4, that's 20. This is 22 to what? Base 10. So we are good to go. It's quite easy. Very easy. Very easy. Now, another example. Let's say you're giving something like 1 1 0 0 1 1 in base 2. Convert to decimal. Let's go again. 1 2 4 8 16 32. Okay. Now, anyone with zeros, you neglect those ones and take the rest. We're going to be having what? 32 plus 16. We're going to be neglecting 8 and 4. And then 2 and what? 1. Now, adding the two of them together, these two will give us, in fact, these three will give us 19. Will give us 19. 19 plus 32 will be giving us 51. Yeah, man. Base 10. So you can see how easy it is. It's quite easy. Okay. So if there's another one in front of this, it's gonna be what? 64. Just like that. And in case if you don't remember how we got all this number, you can still go with your normal way. 0, 1, 2, 3, 4, 5, and 6. This is 2 raised to power 0, 2 raised to power, 2 raised to power, 2 raised to power. So 2 raised to power each of them. 2 raised to power 6 is what? Is 64. Raised to power 5, 32. Raised to power 4, 16. Just like that. So any way you prefer, they are all accurate. Now we have done from binary to what? Decimal. What if you are giving from decimal back to what? To convert to binary? How do you do that? So from the first example given to us, We were trying to get 22 in base 10 to what? Binary. Right? So we're going to be having what? Binary is what? 2. So dividing 2 divided by 2, 22, you're going to be having what? 11, remainder what? 0. 2 into this, you have 5, remainder 1. 2 into this, you have 2, remainder 1. 2 divided by 2, you have 1, remainder 0. And then 2 divided by 1, you have 0, remainder 1. And you collect from down to what? To up. You have 1, 0, 1, 1, 0. Getting backwards, this guy. You see, right? So it's quite easy. Very, very easy. As easy as. Now, let us try for the other, our other friend, which is 51. Let us see if we're going to be getting the same answer in base 10. Okay, let's do it. So we're converting to what? Binary. So we're going to be dividing by what? 2. 50 what? 1. When we divide 2 divided by 51, it's definitely going to give us remainder 1 because it's an odd number. Next one close to this is 50. So 2 divided by 50 is what? 25. So it's going to be 25 remainder what? 1. 2 divided by 25, the closest even number is 24. Divided by 24, you are having what? 12. Remainder what? 1. You have a remainder 1 because it's an odd number. So 2 divided by this is an even number, so we're going to have a remainder what? 0. 2 divided by this is what? 6. 2 divided by 6 is now going to be what? 3. Remainder what? 0. 2 divided by 3 is now going to be what? 1. Remainder 1. And 2 divided by 1 is 0. Remainder 1. Taking it from up to from down to up, we're going to be having 1, 1, 0, 0, 1, 1. This is on base 2. And you can see, where does that come from? You can see this guy and this guy are what? The same. Okay. So we have done through and through. Now, a question just came just kind of, I just thought of a question. Now, what if you are asked to find the decimal or convert something like this, 1, 0, this point 0, 1 in base 2 to what? To decimal, back to decimal. What is it going to be? Now, the normal way when I want to solve this is what? 0, 1, 2. And we then do that our 1 times 2 raised to the power 2 plus that, so on. A gap. Now, remember we started from the decimal point to start counting. So after our 0, the next one is going to be, if you're moving in the left hand side of the number line, you're going to be having what? Minus 1. Here it's going to be what? Minus what? 2. Okay? So we continue. This is now going to be what? 1 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 0 times 2 raised to the power 0 plus 1 times 2 raised to the power minus 1 plus 1 times 2 raised to the power what? Minus 2. Grab. So this is what? Raised to the power 2 is what? 4. Raised to the power this is what? 2. This is definitely going to give us 0 because 0 is here. So 2 raised to the power minus 1 is it going to give us what? This is something as you having 1 over 2, which is something as 0.5, right? That's for your indices. To be 100% sure, like I use a calculator. Okay, I'm correct. So we're having what? 0.5. Now over here, the same thing also goes here. This is 1 over 2 raised power what? So this is 1 over 4, which is going to be giving us 0.25. 0.25. Okay, so adding this stuff, we're going to be having, this is definitely going to be giving us 6. Now this plus this is going to be giving us 0.7. No, 5 is 1. So this is 0.8. What am I saying? 0.75. This is 4 plus 2 plus 0.5 plus 0.25. And I'm correct. So this is the answer in what? Decimal. You grab. Okay. Oh, okay. Now let us now try for what? Hexadecimal. Yeah. Okay. Now our hexadecimal is very easy. As easy as. Okay. Now our hexadecimal, to make work a bit easier for us, we're going to be constructing a truth table for it. Or a table for it. Now the table we're going to be making use of is the normal. Let's not go too far. This is your binary. This is your what? Your hexadecimal. Yeah? Hexadecimal, right? Okay. Remember your hexadecimal is what? The base of what? 16. This is your base 10. This is your base 16. That is your base 2. Okay. Now, let's say we are given stuff like this, and also let's also put it in what? In decimal too. Let's also put in decimal over here. Now, you start counting from 0 to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pardon me to come over here and continue. Allow me to come over here and continue. This is our decimal. This is our binary. And this is our hexadecimal. This is where we stop at 12. Continue from here, we're going to be having 13, 14, and what? 15. Right? This is for our decimal. Okay. Now our 0 in binary is going to be what? 0, 0, 0, 0. Why is it 4? We are stopping at what? 15. 15 is going to be having 4 distance, but we are taking it in fours, So the next one is going to be what? 0, 0, 0, 1. The next one, 0, 0, 1, 0. This is time consuming, but let us do it our normal column way. Okay, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. And if you notice one thing about all this binary this thing, whenever you see an odd number, it normally ends with what? With some 1. And even number ends with 0. Don't know if you've noticed it. Now, the next one is 2 zeros, 2, 1. So this is our second one. 2, 0, 2, 1. 2, 0, 2, 1. 2, 0, 2, 1. The next one, 4, 0, 4, 1. This is our fourth 0, 4, 1. 4, 0, 4, 1. The next one, 8, 0, 8, 1. This is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, so this method is a little easy. Now we have gotten is binary words form of this decimal form. If you try to use that method we just talked of earlier, now try any of this, you get the corresponding words value of is binary. Try in any of them. Try converting from 12 to binary, from binary to, you will get the same thing. You will get the same thing. So we are right on our truth table. Now moving over to now hexadecimal. Now hexadecimal is now going to be what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Someone will say 10. But we're going to be having what? A, B, C, D, E, and what? F. Yeah, man. So we start. The difference between our hexadecimal and our decimal is we don't have 10. From our 10, we start. Oh, we're asking me, what if we have 16? If we have 16, then okay. I'll find that out myself. Okay. So this is for our hexadecimal. This is the table. After our our 9, that's what we're having is what? A, B, C, D, and what? F. So I hope you know this off heart, because we are going to be applying it now. So let us try for this example here. So let us say you're given D1, this is 1, D1 CE in what? Base 16 to convert to what? Binary. How do you do it? Now, our hexadecimal, we normally express it in terms of what? 4s. So each of them is going to be coming with 4. Each of them 4. What did I just say now? Each of them will be expressed in 4 distance. So for this one, what is our D? Our D is what? For our D, we are having what? 1. You can also say your D is what? In case if you don't have this binary or this type of hearts, you can simply formulate it. But another short way, you cannot say if you know what your D is in decimal, it is what? 13. If you, then you can then easily now know what your binary is. But as long as we have our table here, there's no need for this. So we cannot simply go straight. Our binary is what? 1, 0, 1 for our D. Our 1, on the other hand, is what? 0, 0, 0, 1. Our C, on the other hand, is what? What is our C? Our C is what? 1, 1, 0, 0. And our E is what? 1, 1, 1, 0. Now, your binary form is now going to be equal to 1, 1, 0, 1, which is this first one, 0, 0, 0, 1, the next one, 1, 1, 0, 0, 1, 1, 1, 0. Praise the Lord. Now, let us try getting it in decimal. You just got it in binary. Let us try getting it in what? In decimal. Now. Okay. Now, here's in what? Base 16. We want to get it in what? In decimal. How do we do that? Okay. Now, we know that our 1, 2, 4 doesn't work here, because this is not what? This is not binary to decimal. This is not binary to decimal. So it won't work here. It has its own separate rule. So what we're going to be doing here now is giving here 0, 1, 2, and 3. The normal way we know. Now, we're also going to be finding a way to also replace what our D is in decimal. Our D is what? 13. Our 1 is still 1. Our C is what? 12. And our E, on the other hand, is what? 14. So converting this to decimal is now going to be 13 times 16 raised to the power 3. The 16 is from this base here. Now plus 1 times 16 raised to the power 2 plus 12 times 16 raised to the power what? 1, and 14 times 16 raised to the power what? 0. Raised to the power what? 0. Very easy. Very, very, very easy. Now you can now simply what? Multiply. When you do that, you have 13 times 16 raised to power 3 gives us what? 5, 3, 2, 4, 8. This 16 raised to power 2 is what? 2, 5, 6 plus 12 times 16 192 plus 14. Anything raised to the power 0 is 1. You grab. So 1 times 14 is this. Now you simply just what? Add up. So we have our final answer to be what? 53710 base what? 10. Now, you know you can actually use calculator to do all this. But calculation actually has its own limits. It cannot actually solve this for you. So if your invigilator is familiar with the limitations of your calculator, this is the kind of question they would like to give you. The one that they know that you can't simply just formalize from somewhere else. So this one calculator can solve it, but there's a limit to what calculator can solve for you. But still, it's not hard. Don't even know why we need calculator, by the way. Okay, so it is easy. As you have seen, we have converted this hexadecimal both towards the binary and both towards to decimal. So that's all for this video. So one more example before we go. Just one more example. So I saw this one: 2e6 plus a3 in base what? 16. And you're asked to convert it to what? Decimal. It's quite easy. Okay, so here is going to be what? 0, 1, 2. It's going to be minus 1, minus 2. Okay, so we're going to be having, remember, this remains 2. E is what? 14. 6 is still 6. A is what? 10. 3 is still what? 3. So we'll be having 2 times what? E is 14. You grab. So 2 times 16 raised to power 2 plus 14 times 16 raised to power 1 plus 6 times 16 raised to power 0 plus 10 times 16 raised to power minus 1 plus 3 times 16 raised to power minus what? 2. Now we can then solve. 2 times 16 raised to power 2 is what? It's going to be giving us 512 plus 14 times 16 will give us what? Remember the reason I'm saying 14 times 16 is 16 raised to power 1, so it's still 16. So it's going to be giving us 2, 2 what? 4. Over here we're going to be having what? 6. 10 raised to power 0 is 1. So 1 times 6 is 6. Plus for our 10 parts, we'll be having 10 multiplied by 16 raised to power what? Minus 1. And we have our answer to be 0.625. This is for this one. Now over to the next one, raised to power what? Minus 2. We're going to be having 3 times 6 times 16 raised to power what? Minus 2. And we are having our answer to be in a huge decimal number, but we're going to be factorizing. We're going to be approximating to, let's say, a 4 decimal place. So let's say 0.011117. So if we add this up, we're going to be having that our final answer to be, so we have an answer to be what? 742.6367 in base what? 10. Ta-da! So it's quite easy. It's not as if it's hard. It's not hard. Okay, so that's all for this video. Subscribe if you haven't, like, comment, and share with your friends if this was helpful. And keep living your good life. Keep living a good life and be the best in what you do. That particular thing where God used to create you, be the best in it. Goodbye.